Hello, welcome once again to SageMath. In this video, we are going to discuss various symbol operations in SageMath. First, let us see the division operation. Consider this number, consider this fraction 20.0 divided by 14. When we type it in the SageMath in the Jupyter notebook, we get this output. But if we avoid this decimal place, the 0.0 part from the in the numerator, then you can see that it will appear only like in a fraction in the p by q form, not in the decimal form. So as you can see here, see 20 by 14 divided by 14. Okay. Yeah, it is taking time to show the output. The system is taking okay, what does it show? Yeah, no, okay, then we have to start the project. It was not to start. You can see the output now. Okay, once again, if we it has the output is displayed now. See, if we type instead of 20 by 14, if we type 20.4 by 14, and take the output, you can see it displays the number with the decimal places. Many decimal places can be, you can see many decimal places here. Okay, the next we can see a function, the use of a function, the numerical approximation, and this function is used to display the value of a number approximately. See, when we use this function along with the number 20 by 14, this output will be displayed. That means it numerically it displays an approximate value of the number which is given as its argument. But when we use that function with this number, it will be displaying this output. But in our demonstration, we are not interested in using 2 raised to the power of 1000, because that may take a longer time for its calculation. So let's try this numerical approximation to see the that will help you to experience it. You can completely you can copy it and then paste it in the input cell. and then you can, okay, and running it, okay, you can see that output. Okay, next function is so that is the use of now I think you have you have learned the meaning of or the use of this function, numerical approximation. It is used to produce the approximate value of a number. Next we are going to see some very simple operations that are used in SageMath system. A plus b, four operations, four symbol operations are used, can be performed in SageMath. That is the first one is the addition, second is the subtraction, then multiplication and division. For addition, you can write it, the syntax is a plus b, where a and b are two numbers. And for subtraction, for subtracting a number b from a, you have to write a minus b. For multiplying a and b, a star b you have to write, and for dividing b by a number, a by another number b, you have to write a / b. For getting as power function, or for getting exponentiation, you can write a cap, or two ways are there, a cap b or a double star b. For obtaining a square root of a number, you have to write sqrt of a, where a is the number, sqrt of a. And if you want nth root, then you can write a cap. Nth root of the number a can be obtained by writing a cap, then in bracket you should write 1 by n, that is a to the power of 1 by n. And then some other type of operations, the integer operations, which can be called integer operations. These are the special operations, because these operations operates on, it can operate on integer arguments or integer values. See here, the first one is the integer division. Integer division is written as a double / b, a double / b, where a and b then must be two integers. Should note that a and b must be integers. So here all arguments must be integers, a, b, and then if in the function factorial, n must be integer. Likewise, okay. And then the second operator or second function is remainder operator. Remainder operator. How does the remainder operator work? Remainder, that operator needs two arguments, a and b, and when you write a, the percentage is the symbol used to represent the operator. So when we write a percentage b can give us the remainder when the number a is divided by b. So first you have to divide, or the system divides a by b, and it checks the remainder, the value of the remainder, and that value will be given by the system. Next operator is quotient and remainder. The quotient and remainder operator, and that function is div mod, and then in bracket you have to write the two integers a and b separated by commas. So div mod should take you should give attention to that. And div mod should okay, div mod, and then in bracket a comma b, and then comes the factorial operator, the factorial function, factorial n factorial. N factorial, that is written n then exclamation mark n factorial, and that function actually it is it's written in mathematical language, it is written n factorial, but here we will write it as factorial in the full form, factorial factorial, and in bracket you have to give the integer. Next one is the binomial coefficient. That is NCK. The binomial coefficient is obtained by using binomial, binomial, and then in bracket n comma k can be given. Next set of functions, a third type of functions which are discussed, which are given here, is usual functions on real numbers. The usual functions on real numbers and complex numbers, etc. That means usual kind of functions. So first one is the floor function. It gives us the integer part of the given number, integer part of a real number given to it. That is FLOR, floor function. That is FLOR of A. And then if you want the absolute value or modulus of a number, you have to use ABS of A, ABS in bracket A you have to give. And then elementary functions, there are a set of elementary functions that we mainly use in mathematics, and those elementary functions have their own representation in SageMath. They are for example sine, cos, etc., and those functions then are given in here. Those functions are given in a table here. For that you have to refer the table 2.2. Okay, we will go to the table 2.2, see the table, and this is the table 2.2. In the table you can see those functions are the elementary functions are given. The exponential and logarithmic function. Exponential function is written, its syntax is exp. Logarithmic function has syntax log. And logarithm in the base, if you want to specify the base also, then it should be written log in bracket x comma a. So that means logarithm of the given number x is the given number with the base a. In the base a will be given by this function. So logarithm, its syntax is, once again, its syntax is logarithm of x in bracket x comma a. The trigonometric functions. The trigonometric functions, it's very popular, commonly used by mathematics students. Frequently used by mathematics students. And they are sine, cos, and tan, sine, cos, tan, etc. And those functions should be written as they are available here, as shown here. And then inverse trigonometric functions are arc sine, arc sin, arc cos, arc cos, and arc tan. Similarly, hyperbolic functions can be written sin h, sin h, cos h, and tan h. And inverse hyperbolic functions are arcs in h, and arc cos h, and arc tan h. Then integer part of integer part, etc. They are that category of functions. There are 4 functions in that category: floor, ceil, 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 trunc, truncation, trunc, and round, round. And these are integer type of functions. That means it gives us integer output. Whatever value you give as its argument, as its input, then that function will be giving you an integer answer. Then comes the square and nth root, the square function, the nth root function. Square root we have seen already some steps back. We have seen that square root can be written as SQRT, and now we have nth root. Nth root should be written nth this subscript nth subscript root. So note that, very important. Its syntax very important. You should not make any mistake while writing all this, because it's very important that you should not miss any letter, or you should not add some additional letter while writing the function, or you should not replace one letter by some other letter. So all those are erased. It will all those acts will result into erase, and that will cause that's non-generation of output. You generating it will not generate the output of the function or the statement that you use in the system, in the SageMath system. Okay, now rewriting trigonometric expressions. Rewriting trigonometric expressions. See the function simplification, line linearization and anti-linearization, and these functions they have specific uses, and first one is should be written as SIMPL IFI subscript TRIG, reduce subscript TRIG, and expand subscript TRIG. So these are the functions mainly we want to discuss. To mention only, we are not discussing this. We haven't discussed these functions in detail. You can have more experience on using this function later when we discuss, when we use more complicated expressions in which these functions are used. So okay. Then we can now come back to the point where we skipped. Where we shifted to, from the point where we shifted to this table. Now that's what many steps back. Okay, now let's see how these functions can be some examples, some examples of using this function in the COCAG, in the COCAG system and the SageMath system. See some examples we can try. For example, sin x plus, okay, now sin x, let's try this sin x and then start project, because if we are not using the project for some time, if we are not using the SageMath or the COCAG project for some time, it then automatically it quits it, and or it blocks it, and then when you come back to that system after some time, it will display that it is not open, the project is not open. So first then after some time, if you want to resume that, then you have to reopen it. That means you have to click that open the project, that button you have to click to open it. Now this is again reopened, that project is now reopened, and so sine okay, sine okay, sine, then sine 20, anyway, I have written sine 20, and then it shows only sine 20. You can see here it displays only sine 20, and it is not showing any value. But what is going to do when we write it in a different way. See, for example, consider this y is equal to, I am using here a variable. Okay, sorry. Yeah, y is equal to sine sin sine 20, y equal to sine 20. Okay, and then in the next step, okay, I type y, and y is to y. Okay, then shift enter. What does it display? It also then displays the same thing. It displays the y, the value. It displays the value of y. It displays y is equal to, it again shows that y is equal to sine 20. Okay, but if you want to obtain the value, actually you can try this this one, that command you can try if you want actually the value of then y. If you use y inside, and then what is going to be displayed? Let's try it, and okay. Yeah, you can see that it displays. So using that numerical approx function, you can display actual value of the value of that function. Yeah, that is the use. So it's other illustration of the numerical approximate function. Directly this shows that the functions do not directly straight away give the actual function value in the numerical form. So if you want to display the actual value of the value produced as the output of a function, you have to use that function, numerical approximation numerical approximation function you have to use. Okay, then okay, then let's see how some different type and different ways of writing this. Let's discuss. See, I am going to define some more functions. Sorry, a variable. I am going to define a variable here. Here x is a variable. I define. I have defined x as a variable, and x is given the value to the. Okay, sorry. It is given the value 20. 20 is the value given to x, and then I write, and in the next line I write y is equal to so by writing y, I have already I have written y, and I have used y. Now again I am writing y. Y is equal to, I am going to assign that value. Y is a variable. I am going to assign the value sine x. I will assign sine then x. I am assigning sine x. Okay, then I want to display something. Yeah, if I try shift enter, what does it show? It doesn't show it doesn't show anything. Yeah, it's because nothing is asked to display. Actually, I haven't asked. I didn't ask anything to display to the system. So, but now you can ask once again. You can ask to display x, and also you can ask to display y. See what happens. What will the system do then? Yeah, it displays only sign, but it doesn't display the value of x. It displays only the value of y, because x is equal to 20, and y is equal to sin x. So since x is pre-assigned to the value 20, and it comes to it comes at the place of x, and it becomes sin 20, and that is then assigned to the variable y. So when I write y here, and since that is the last line, I typed in the input, it will display the content of that variable. That variable will be then displayed. It is sin 20. Okay. So if you want the numerical value, actual value, you can write this statement. Numerical approximation y, instead of y you can use that. Okay, these are some symbol some symbol demonstrations of symbol functions in SageMath programming. Okay, thank you.